Good evening, all. I'm posting this to hopefully be a good assistance as you prepare for the test on Friday. This is homework limiting and excess reactants. I'm going to go over all of these questions. If you'd like to go quickly through the video, I will show an answer key at the very end. So if you want to fast forward there, but otherwise, I will show you each step on how to do these problems. Note, remember to use the limiting reactant when calculating the amount of products. Question 1 says balance the equation for this reaction and answer the questions. So first, let's go ahead and balance this equation. If you remember how to do that, we will want to, let me make my pencil a little, can I do that? Oh, my pencil's not working. Here we go. Make it smaller. We list out each element that we have. We have nitrogen, and we have hydrogen on the left and right. We currently have 2 nitrogens. We have 2 hydrogens. Then over here, how many nitrogens do we have? We have 1. How many hydrogens? We have 3. Our first step is we're going to balance metals, but we don't have any. Then we'll go to non-metals, which in this case represents nitrogen. To turn nitrogen from 1 to 2, what do we have to do? Multiply by 2. And that 2 represents our coefficient. So I'm going to put that right there. So now we have 2 nitrogens. But note, whenever we multiply by that 2, does it just hit the nitrogen? No, it multiplies the hydrogen as well. Specifically, it hits the 3. So what does 3 times 2? 6. There are 6 hydrogens on the product side. Are our nitrogens now balanced? Yes. Now, let's balance the hydrogen on the left side. Currently, we have 2, but we want 6. What do we have to multiply 2 by to equal 6? We'll have to multiply by 3. What does that 3 represent? Our coefficient. So our coefficients are in order 1, 3, 2. Okay, let's look at our question. If 75.0 grams of nitrogen and 18.75 grams of hydrogen are used for this reaction, which reactant will be the limiting reactant? Show your proof. So let me erase my work right here so it's not distracting. 1, 3, 2. Our first step, we are going to see how much of hydrogen do we need to react with this, our current given, and then how many of nitrogen would we need to react with this, our other given. So note, our first step is we're going to convert both of our givens, convert both of givens to the other reactant in the same unit. I say same unit because note we did an example in class today where we did it with moles, but in this one, what unit are we using? Grams. So note, we're going to convert each of our givens. How many do we have? 2. We're going to convert each one individually to the other reactant. Remember, the reactants in our equation are those 2 compounds on the left. We're not going to be considering anything about the product side. We're just looking at the reactants. So, our first given. I'll say this is number 1. I'm going to try to write it a little smaller. We put what we're given. This is just stoichiometry. Hopefully you feel somewhat comfortable with this. We're going to convert our grams of nitrogen into grams of hydrogen. In order to do that, we're going to have to do a lot of molar conversions. Convert grams of nitrogen into moles of nitrogen. Convert moles of nitrogen to what? Oh, I wrote that really wrongly. I'm sorry. I got excited. Convert moles of nitrogen to moles of hydrogen. And make sure you're staying consistent. Going diagonal. Going diagonal. It has to be the exact same unit and compound. Grams of nitrogen, grams of nitrogen. Moles of nitrogen, moles of nitrogen. Make sure you're consistent. If you're not consistent, you're going to make your life a little difficult. So make sure you're consistent. That's a good spiritual application. Consistency. Moles of hydrogen into, what was our final desired unit? Grams. Grams of hydrogen. Again, recall that heart diagram where we're going from grams, that represents mass, to moles to moles, and then moles to grams. Okay, let's fill in these numbers real quick. How many grams are there in nitrogen gas in 1 mole? Because remember, we're always dealing with how many grams per 1 mole. In this case, it's going to be nitrogen's molar mass, which is 14.01 times 2, since we have 2 of them, so that's going to be 28.02. Point. Then, moles of nitrogen to moles of hydrogen. What do we have to look at? Are we going to put 1 at either one of these? Well, we may. It depends on what? Our coefficients from our balanced equation. Look up here. We did that at the beginning, right? So what is the coefficient for nitrogen? Well, according to this, it's going to be 1. What's our coefficient for hydrogen? 3. Okay, next. Now we're converting moles of hydrogen into grams of hydrogen. What number goes beside moles in these conversions? 1. What number goes beside moles in these conversions? 1. If you put any other number beside that mole in a molar conversion, going from moles to grams or moles to liters or anything like that, your life will be very, very, very unhappy in these stoichiometry problems. How many grams of hydrogen are in 1 mole? We have to calculate using molar mass. It's going to be 2.02. Hydrogen has a molar mass of 1.01, but since we have 2 of them, multiply by 2. But in this step, we would go ahead and multiply all across the top. And all across the top is going to equal, got 75.0 times 1 times 3 times 2.02. I got the number 454.5 divided by 28.02 times 1 times 1 times 1. That's 28.02. That number should equal 16.2. I started with 3 sig figs. I'm going to finish with 3 sig figs. 16.2. What's our units? Well, if we look at it, grams of nitrogen canceled. I'll use red instead. Moles of nitrogen canceled. Moles of hydrogen canceled. Leaving us with grams of hydrogen. That's why it's so lovely to make sure you always keep these units shown. Unit and compound. Grams of hydrogen gas. So, if we're given 75 grams of nitrogen, how much hydrogen do we need? How many grams of hydrogen? We need 16.2. If that's how much we have, 75.0 grams of nitrogen needs 16.2 grams at least of hydrogen. Now, let's do the other one. I'm going to go a little faster this time since you know the process. We put what we're given. And by the way, we're converting each of our givens to the other reactants in the same units. What's the other reactants besides hydrogen? Nitrogen. So now we're going to convert hydrogen into nitrogen using what unit? Has to be the same. Grams. So, put what we're given on the first, 18.75 grams of hydrogen. I'm going to go a little faster. Times, what do I put on the bottom? I don't know. I'm freaking out. Just go downward. Look where you were. Just go downward. Diagonal. Grams of hydrogen. What are we turning grams of hydrogen into? Well, ultimately, grams of nitrogen, right? But we can't just go straight there. We have to go by the way of the mole. It's like the song, By the Way of the Cross, right? But in stoichiometry, you have to go by the way of the mole. To heaven, we have to go by the way of the cross. Okay, so I went from grams to grams to moles of hydrogen. Now we're going from moles of hydrogen to moles of what? Nitrogen. And then I'm going to go from moles of nitrogen. Note, if I forget any of these railroads, am I going to mess up? Yes. So be very methodical. This is such a methodical process. We're now converting from moles of nitrogen to grams of nitrogen. There's our correct setup. Now let's get our numbers. Note, this first one, it's a mole to gram ratio, so what number always goes beside mole? 1. How many grams per 1 mole? What is our molar mass of hydrogen? Well, it's 1.01, but since we have 2 of them, it's going to be 2.02. How do we figure out what numbers go beside our mole-to-mole conversion? We look at the balanced equation. What number is beside hydrogen? 3. What number is beside nitrogen? 1. Then, how many moles of nitrogen are in grams of nitrogen? Again, we're going to put 1 beside moles of nitrogen because we're doing a mole to gram conversion. 1 goes beside moles. How many grams per 1 mole? And the molar mass of nitrogen is 28.02. 14.01 times 2. We do all of this math. We're going to multiply 18.75 times 28.02, which should equal 28.02 times 18.75. That equals 525.375 divided by 1 times 2.02 times 3 times 1. So basically it's just going to be 3 times 2.02, which should equal, 2.02, 6.06. Once we do that quick math, 525.375 divided by 6.06, that should give us 86 point, let's run that at 7, no, we need to go ahead and round that to 70. That's using sig fig rules, because if you remember, we were given how many grams? How many in our start? We're given 1, 2, 3, 4, so we want to have 4 in our answer. We have 1, 2, 3, 4. Our number was 86.6955 going forth. But sig fig 1, sig fig 2, sig fig 3, sig fig 4, so that's what we're going to round. That rounds it up to 86.7. But this is only 3 sig figs, so we would add 1 more 0. And that would be 4 sig figs. Okay. What am I missing? Hopefully you know this by now. Hopefully you feel something's off. We're missing our units. So let's go back. What canceled? Grams of hydrogen canceled. Moles of hydrogen canceled. Moles of nitrogen canceled. Why are they canceling? Because they're diagonal. Grams of nitrogen is what we're left with. Grams of nitrogen. So, if we look at this, whenever we're reacting to 18.75 grams of hydrogen, we need 86.70 grams of nitrogen if we want the reaction to go to completion, to go completely through the whole process. So, let's look at it. We're given, I'm going to write this information down. We're given 75 grams of nitrogen. That's how much we have. This represents how many is right in front of us. If we're in the lab, that's how much we have. Given 75.0 grams of nitrogen and 18.75 grams of hydrogen. We need, my pen's being a little slow, I'm so sorry. We need, according to our calculation, how many grams, or let's do it in order. Let's look at nitrogen first. We need 86.70. 86.70. That should be a decimal. Of nitrogen. That's what we just calculated, right there. And for hydrogen, we need 16.2 grams. Okay, which one do we have excess of? If we look, comparing these two numbers, We have how much? We have 75. How much did we need? 86.70. Do we have more than what we need of nitrogen? No. For nitrogen, we have less. So that's going to be our what? Our limiting, my pen is very slow, limiting reactant. And if we look at the other one, the hydrogen, note, if we look at this, how much are we given? 18.75, that's how much is right in front of us. But how much do we need? 16.2. Do we have enough? Yes, this is how much we have. We have 18.75 grams. How many do we need? Only 16.2. So what would hydrogen be considered? Our excess reactant. I'm just going to put R to save some space for what we're about to do. Okay. Now we have answered A. Again, this might have felt like a long time, but I'm explaining each step thoroughly. The more you do this, the more comfortable you get. It should take a little faster. How much of the excess reactant will be left over? How do we figure that out? To figure out how much of the excess reactant will be left over, hopefully you guessed it, we're going to just take these two numbers. Our excess reactant is hydrogen. We're going to take what we were given, or what we have, 18.75, and then subtract what we actually needed. So how much will be left over? It'll be about 2.6 left over. 2.6 grams of hydrogen. There's our answer. I'm going to pause the video to see if I can get some better connection, then I will make the next video.